Okay, this video is going to go over the test review, so let's go ahead and get started. This first part here, they want you to represent an interval either as an inequality or in interval notation. So this first one, you go from 4 to positive infinity. As an inequality, that would look like 4 is less than x, which is less than positive infinity. In interval notation, it would be parentheses 4 comma positive infinity. And I'm using parentheses here on this 4 because it's an open circle at 4. So this next one, you go left forever to negative infinity, and you go right forever to positive infinity. As an inequality, that's negative infinity less than x less than positive infinity. And in interval notation, that's parentheses on both sides. This is also referred to as all real numbers. So if you see all reals, and it might have like a little R kind of thing with a line through it, that's what it's talking about. Okay, this next one, they say from 5 to 8, and 5 has a bracket, so on a number line, this would look like this. Here's 5, here's 8. At 5, it's a closed circle. At 8, it's an open circle, and then connect those. So as an inequality, that would look like 5 is less than or equal to x, which is less than 8, like that. And then this last one, they gave it to you as an inequality. So on a number line, it would look like this. It's going left forever to negative infinity. And then at 15, it's going to have a closed circle. So it would look something like this. So it's going left forever. As an interval, it would look like parentheses negative infinity, comma 15 with the bracket on the 15. And then in terms of finite or infinite at the top here, basically if you have infinity as part of your answer, it's infinite. So like this first one, 4 to infinity makes it infinite. The second one, it goes to negative infinity and positive infinity, so that's infinite. The third one, it just goes from 5 to 8, that's finite. And then the fourth one, it goes from 15 all the way down to negative infinity. That's infinite. Okay, moving on. Complete the chart. Okay, this first one, the domain as an inequality, well, it's going left forever and right forever. So from negative infinity to positive infinity on the domain. So that's all real numbers. As an inequality, that's negative infinity is less than x, which is less than positive infinity. As an interval notation, it's parentheses on both. Okay, now the range of this is how low it goes, how high it goes. Well, these arrows mean it's going to go down forever to negative infinity. And the highest that it goes would be this point right here, which is at a y value of 3. So to write this as an inequality, the lowest that it goes is negative infinity, less than y because we're talking about range, and then less than or equal to 3. And I'm using the or equal to here because it is a closed circle up there. It actually hits that y value of 3. In interval notation, it would be parentheses negative infinity, comma 3, and the 3 has a bracket. In the end behavior of this, if I go left, so let me format it as x goes to negative infinity. That's like if I hop on the line and start going left this direction, I'm going down. So my f of x would be approaching negative infinity. And if I go right, so as x goes to positive infinity, my f of x is also going down to negative infinity. So if I went right, I was going down as well right there. Okay, the second one, the domain is how far left it goes, which would be here. How far right it goes, which would be here. So notice here it's a closed circle and here it's an open circle. So when I write this, my domain, how far left I go is negative 5, and it's got a closed circle. So I use the or equal to there. And then how far right it goes would be 4, and it's an open circle, so I don't need the or equal to there. So as an interval notation, it would be bracket negative 5, comma 4, parentheses. The range is how low I go, how high I go. Well, here's the lowest that I go at negative 6. Here's the highest that I go at 4. So if I was writing the range of this, it would look like at -6, it's got a open circle. So I just used the less than symbol. And at 4, it's got a closed circle. So that's when you need the or equal to. As an interval notation, it would be parentheses -6, comma 4 bracket. And this one doesn't have any end behavior because there's no arrows on the end. So you don't need to worry about end behavior there. This last one, the domain, it goes left forever and it goes right forever. So the domain is all real numbers. So everything from -infinity to +infinity. And the range, this goes down forever and this goes up forever. So the range is all real numbers as well. Just make sure you put a y in there when you're talking about range. Now the end behavior as x goes to -infinity, f of x is going to, that's like if I hop on the line and start going backwards on it, start going left, my arrow at the end is going down to -infinity. Now the other end behavior as x goes to +infinity, it's like if I hop on the line and start going right, I'm going up at the end. So f of x would be approaching +infinity. And f of x is just another fancy way of saying the letter y. Okay, state the domain in the range of the function in interval notation, then describe the end behavior. So the domain in interval notation would be how far left it goes, how far right it goes. It goes left forever, right forever. So the domain is all reals, and in interval notation, that's parentheses -infinity, +infinity, like that. And then the range is how low it goes, how high it goes. So the lowest that it goes would be this point right here, which has a y value of -5. How high it goes up forever, so +infinity. And at -5, it hits this point. So I'm going to be using a bracket there, like this. And then the highest it goes, we said, was +infinity, like that. Okay, and then the end behavior of this as x goes to -infinity, f of x goes to, it's like if hop on the line at any spot and start going backwards on it, start going left, find out what you're doing at the end. It's going up to +infinity. And then the other one as x approaches +infinity, f of x is approaching, hop on the line at any spot and start going right and see what you do at the end. It's going up as well to +infinity. Okay, this next page. Okay, on the second page here, state the domain and range of the function in inequality notation, then describe the end behavior. So the domain is how far left, this arrow is going to go forever left to -infinity. How far right, that would be here at 4, and it has an open circle. So the domain in inequality notation would be -infinity is less than x, which is less than 4. The range is how low it goes, how high it goes. So how low it goes would be this point right here. That's at -2. How high it goes, this arrow means it's going to go up forever to +infinity. So my range here would be -2 is less than y, which is less than +infinity. And then the end behavior of this line, it only has one end behavior because it only has one arrow. So the end behavior would be as if I go left. So as x approaches -infinity, f of x is doing what? And so you look at this arrow and it's going to continue to go up forever. So that f of x would approach +infinity. And again, there would be no end behavior to the right because there's not an arrow there, it's just an open circle. Graph the function with the given domain and state the range. So 1/2 x plus 3, start at your y-intercept, rise 1, run 2. Work your way back a little bit, connect the dots. So this line would look something like this. But then they say they want to restrict the domain to -4, which is here, and +2, which is here. So that means I'm not going to need anything to the left or to the right of those points. I just care about this section of line. And then get your endpoints correct. So this one, they both have or equal to's. That means it's going to be closed circles at those points. So this is what that line would look like with the restricted domain. And then they want you to answer the range. So how low it goes would be here. How high it goes would be here. So from 1 to 4. And they're closed circles in the end. So I'm going to use brackets from 1 to 4, like that. Okay, this next one, negative 2/3 x minus 1. Start at your y-intercept of negative 1. Drop 2, run 3. Work your way back up a little bit. Connect the dots. So this is what that function would look like if I don't restrict the domain. However, they say they want to restrict the domain from negative 3 to positive infinity. So from negative 3 right here all the way to the right. That means I don't need anything to the left of negative 3. And then at negative 3, they used a parentheses there. So it's an open circle at negative 3, like that. And so now the range of this line, how low it goes, this arrow means it's going to go down forever to negative infinity. How high it goes would be here at 1. And notice it's an open circle at 1. So my range would look like parentheses negative infinity to positive 1 with the parentheses there. The graph on the right, state the domain. How far left it goes would be here at negative 7. How far right it goes would be here at positive 7. So it's negative 7 to positive 7. And they have closed circles on both ends. So it's brackets on both. Like that. The range is how low it goes, which would be, this is the lowest point. So that's at negative 5. And then the highest point, this is the highest point. So that's at 6. And they're closed circles on both. So it's from negative 5 to 6 with brackets since they're closed circles. Name the intervals of increase, decrease. Work your way left to right on the line. So this section right here is increasing. And you want to answer this using your x values. So it's increasing from negative 7 x value to x value negative 5. So my increase would look like negative 7 to negative 5. My next section of increase would be this section right here. That's from an x value of negative 3 to an x value of positive 3. So union, negative 3 to positive 3. That's my only increasing sections. Now decreasing would be this section right here from negative 5 to negative 3. And then this section over here as well. That's from positive 3 to positive 7. Okay, the local maximum are the hills like these, but not the highest point. So this right here, this circled red point, is a local max. It has a value, a y value of 5 at an x value of positive 3. And again, for those, you might write the coordinate like 3, 5, and you care more about the y value. The local minimum, there are 2 of them. They are here and here. So if it helps you, go ahead and write those coordinates, negative 7, negative 2, and then this one's at negative 3, negative 4. So I would say the local minimum has a value of negative 2 at an x value of negative 7, and the other one is negative 4 at an x value of negative 3, like that. The absolute max and the absolute min, you care about the y values. So this is the absolute max and this is the absolute min. If it helps you, write the coordinates. So this one's negative 5, 6. And this one is 7, negative 5. And so the absolute maximum, this one up here, has a y value of 6 at an x value of negative 5. And then my absolute min, this one right here, has a y value of negative 5 at an x value of positive 7. All right, this last page here, they're asking me to do transformations of a parent function. This is my parent function. And so basically to start this, the first thing I did was I wrote down the coordinates of those points. So like these points right here. I wrote down the coordinates into a table because I'm going to have to apply transformations to them. And when you're moving a weird looking shape like this, it kind of helps to have a table to do the math in and get your final coordinates with. So let's just start with this number 15. They want me to apply a 1/2, to the y values. That's a vertical compression by a half. So it's outside, it's affecting the y values. So I'm going to put it over here. And when it's outside, you do what it says. So this is like a times 1/2 out here. So all of these y values are going to get times by a half. So this would be 0.5, 2, 0.5, 1, and 0.5. Now, the other side of that, or the other transformation there, is this +2 inside. It's affecting my x value because it's inside. So I'm going to put it over here on the x. And you're going to do the opposite of what it says. So instead of adding 2, I'm going to subtract 2. So I'm subtracting 2 from these x coordinates right here. So now I've got -5, -4, -3, -2, and -1. Now when you go to graph this thing, you're going to want to use the outermost coordinates, so these and these, as xy coordinates. So -5.5 would be here, -4, 2, -3.5, -2, 1, and -1.5. Now just go and connect the dots. So as you can see, if you look at the parent function, this first transformation compressed it vertically by a half, and then this transformation was a horizontal shift left 2. Okay, this next problem, I'm kind of doing the same thing. The first transformation I see is here. That is inside, so it affects my x values. So I'm going to put it on my x side, and it's a reflection across the y-axis. So basically all you need to know is you're timesing by -1 here. So it's going to make these, I'm using these coordinates and I'm timesing them by -1. So it's 3, 2, 1, 0, -1. Okay, and then the second transformation would be this one right here. That is outside, so it's vertical, so it affects the y. So I'm going to put on the y side. And when it's vertical or it's affecting your y values, you do what it says. So -1 on these values right here. So it's going to be 0, 3, 0, 1, 0. Now, same thing, go to graph it using the outermost coordinates. So 3, 0, 2, 3, 1, 0, 0, 1, and -1, 0. Connect the dots. Done. And as you can see, it shifted down 1 vertically, and then it reflected across the y-axis. So like this section of line right here used to be there, and it flipped across that y-axis. So that's what's happening on the reflection part of it. This third one, number 18, same thing. I'm going to start with my first transformation. That's a 2 out in front. This 2 out in front is a vertical stretch times 2. It's outside, so it affects my y values, so I'm going to go ahead and times by 2. So I'm timesing these values by 2. So 2, 8, 2, 4, 2. The next transformation I see would be this -1 inside. It's inside, so it affects my x value. So I put it over here by my x, and since it affects the x values, I'm going to do the opposite of what it says. So I'm actually going to add 1. So now I'm at -2, -1, 0, 1, 2. And then the last transformation would be this guy right here, the -3. And he is outside, so he's affecting my y values. So I'm going to put him on the y side, and I'm going to do what he says, so -3. And I'm applying it to these points, the outermost points. So -1, 5, -1, +1, -1. Now, same thing, go to graph it using your outermost coordinates. So -2, -1, -1, 5, 0, -1, 1, 1, and 2, -1. So this one looks like this. And so if I was naming these transformations, this is a vertical stretch times 2. This is a horizontal shift right 1. And this is a vertical shift down 3. Okay, the last section asks me to describe these transformations. So starting with number 20, this first transformation is outside, so it has to be vertical. And it is multiplying that f. So when you multiply, you're doing either a stretch or compression. Timesing by 7 would be a stretch. And then the second transformation would be this -2. That -2 is inside, so it has to be horizontal. And when it's plus or minus, it's automatically a shift. And so this one is kind of the opposite since it's inside and it's horizontal. So instead of minusing 2 on my x, I'm going to add 2 on my x, which means it's going to the right 2. This next one, my first transformation is a minus out in front. That is a reflection across the x-axis. The next transformation would be this +1 inside. It's inside, so it automatically has to be horizontal. And when it's a plus or a minus, it's automatically a shift. But you kind of have to do the opposite, so you're really going to be minusing 1, and minusing 1 on your x is going to shift you left 1. And then the last one would be this +6. It's outside, so it automatically has to be vertical. It's a plus or a minus, so it's automatically a shift. And since it's outside, you do what it says, and adding 6 to vertically would be going up 6. Okay, these last two, the first transformation is here, the 1/4. That is outside, so it has to be vertical. It is timesing the f, so that means it has to be a stretch or a compression. Timesing something by 1/4 is compressing it. So this would be a vertical compression times 1/4. The second transformation would be this -5. That is outside, so it has to be vertical. It's a plus or a minus, which means it's automatically a shift. Since it's vertical, you would do what it says and you would subtract 5, and subtracting 5 vertically moves you down 5. And then this last problem, the first transformation is this minus on the inside. That's a reflection. And that is across the y-axis. And then this +1 at the end is outside, so it has to be vertical. And it's a plus or a minus, which means it's a shift. And since it's vertical, you do what it says, and adding 1 to your y values would actually move you up 1. Like that. So I hope this video helped. If you have any more questions, feel free to message me, and good luck on your test.